Welcome to this explainer. Today, we're going to take some of those really fundamental, kind of abstract coding concepts and apply them directly to a super cool, space-themed Python project. Let's dive right in and make these ideas visual, practical, and honestly, a lot of fun.
Here's our roadmap for today. We've got three main stops. First, the 4 pillars of OOP. Second, building a Mars weight calculator. And third, scaling that up to all the planets.
All right, section 1, the 4 pillars of OOP. We're going to start by totally demystifying some heavy programming jargon using everyday objects you interact with all the time. So here they are, the 4 foundational pillars of object-oriented programming, or OOP for short: encapsulation, abstraction, inheritance, and polymorphism. Now, I know they sound like intense textbook jargon, right? But trust me, the logic behind them is actually beautifully simple. Let's kick things off with encapsulation. Just think about your smartphone, or even a basic TV remote. Encapsulation is basically the practice of hiding all that complex, messy data and those internal components, the signaling circuits and motherboards, inside a neat little plastic box. We really don't want the user messing with the raw circuits. Instead, we encapsulate all of that and just expose a few simple buttons or a touchscreen. We pack the data safely away and only give you the interface you actually need to get the job done. Next up is abstraction. This is where we hide the sheer complexity of an operation behind a super simplified interface. Think about driving a car. When you're out on the road, you are operating a highly complex machine, right? You've got fuel injection, transmission gears, intricate braking systems, but the car hides all those internal mechanics by giving you just a steering wheel, an accelerator, and a brake pedal. Abstraction literally hides the complex code to make operations way easier for the end user. Now, because these two get confused all the time, let's just compare them side by side. Encapsulation is primarily about data security and organization. It's about packing things safely in a container. Abstraction, on the other hand, is all about user experience. It hides the complex logic so you don't have to be a certified mechanic or an expert coder to operate the system. Okay, moving on to our third pillar, inheritance. The absolutely crucial point here is code reusability. If you've ever played video games like GTA or PUBG, you know there are dozens of different characters. But guess what? A programmer doesn't write the code for running, jumping, and shooting from scratch for every single character. No way. Instead, they write a base character class with all those core mechanics. Then new specific objects like an enemy sniper or your personal avatar simply inherit those base mechanics while adding their own unique stats or outfits. It saves a massive amount of time. And that perfectly sets us up for our final pillar, polymorphism. The word literally translates to many forms. Polymorphism dictates that a single command can behave differently depending on the specific object it interacts with. Imagine you have a general command in your code called animal sound. If you send that command to a dog object, it returns a bark. But if you send that exact same command to a cat object, it returns a meow. It's one single instruction producing multiple different forms of output. Pretty cool, right? All right, section 2, Mars weight calculator. Now that we've nailed down the core concepts of OOP, it's time to take this from theory to a really fascinating Python application. Did you know NASA actually uses Python for flight modeling software? It's true. So, inspired by NASA's Perseverance rover and the Ingenuity helicopter, our first big milestone in this explainer is writing a Python program to calculate your exact weight on the surface of Mars. To pull this off, we need to understand the physics. Because of its weaker gravity, a human's weight on Mars is exactly 37.8% of their weight on Earth. So, our gravity constant for this calculation is going to be 0.378. Let's walk through the logic of our program sequentially. First, we need to ask the user for their weight on Earth. Now, since weight isn't always a perfect whole number, we want to capture this input as a float, which is just a data type that allows for decimal points. Second, we take that input and multiply it by our gravity constant, 0.378. And finally, we need to present that answer cleanly by rounding the result. Actually, let's zoom in on that final step for a second. When you multiply floating point numbers in Python, you can sometimes get this incredibly long, ugly string of decimals in your output, like 25.333333, and so on. To prevent that mess, we use Python's built-in round function. You just pass your calculated weight into the function, tell it exactly how many decimal places you want, let's say 2, and it beautifully formats your final answer. Section 3, scaling to all planets. because as we know, Mars isn't the only planet out there, and a great programmer is always looking for ways to scale their code. So here is our ultimate challenge. How do we calculate weight across all the planets without writing endless if-else code blocks? I mean, writing a separate calculation like if planet equals Mars, multiply by 0.378, if planet equals Venus, multiply by 0.88, that would be exhausting. It's messy, and it is definitely not the smart way to code. We absolutely need a cleaner solution.
Just look at these varying planetary constants. The physics change wildly depending on where you are. Mercury is at 37%, Venus is at 88%, and check out Jupiter. Because it's a massive gas giant, your weight would spike by 236%. We need our program to effortlessly pull these exact numbers based on whatever planet the user happens to type in.
The elegant solution here is a Python dictionary. A dictionary is a super handy data structure that lets us map a key directly to a value. So we can create a dictionary where the name of the planet is the key and its specific gravity constant is the value. This setup allows the program to instantly look up the correct math without sifting through dozens of lines of clunky if statements. With our dictionary in place, the logic becomes incredibly streamlined. We prompt the user for their Earth weight, and then we ask them for their planet of choice. By passing that user's planet string directly into our dictionary as the key, the program automatically pulls the exact correct gravity constant. We do the multiplication, round the result, and print it out. Bam! No repetitive code required.
Of course, we live in the real world, and let's face it, users make typos all the time. Someone is definitely going to spell Jupiter wrong. To catch this, we just wrap our dictionary lookup in a simple condition. We check if the input exists in our dictionary first. If it doesn't, a simple else statement at the very end gracefully handles the error by displaying a message like, "Please enter a valid planet name." This ensures our program doesn't just crash and burn. We've covered a lot of ground today, from the core pillars of OOP to building a fully functioning, scalable space calculator. So as you move forward in your own coding journey, I want to leave you with this question to chew on. If you can cleanly map planets to gravity constants to avoid messy code, what other complex real-world logic could you simplify in your next project using Python dictionaries? Think about it. Thanks for joining me on this explainer, and keep coding.